Good morning. In this video, I'll show you how to write explicit equations. So we have our sequence 5, 10, 15. Very easy. We know that the pattern is adding by 5. I'm sorry. Okay, we're adding by 5. So we know that it's an arithmetic sequence. Because we're adding 5. Okay, so if you saw the previous video on recursive equations, I'm pretty much doing the same thing. We need to know this stuff in order to write our equation, in order to decide what equation to use. So because we're using, because this is an arithmetic sequence where we're adding 5, we're going to use, or we're going to write our equation as a line, kind of as a line, not exactly, because the y changes to t of n. So let me go ahead and write it down, t of n. The m stays, the x becomes n, and then we have a plus b. So that's the equation that we're gonna use. This equation right here. Now, let me show you, or maybe let me say some things. This means, actually, no, wait. This means, this is the pattern. And then this right here is our zero term. If it existed, I know it doesn't exist, but I have to find it if it did exist. So zero term. Okay, so now let's go ahead and write our equation. I'm going to start with a t of n. That doesn't change. So I know that my pattern is adding 5, so I'm going to put a positive 5. The n doesn't change, that stays there. And then if I need to find my zero term, I need to go one before. So if I'm adding 5, going forward I'm adding 5, going backwards I should subtract 5. So 5 minus 5 is 0. So that would be just plus 0. Or I can just not write it down. So this is my equation. Now, there are some tricks to writing this sequence. Sorry, not this sequence. This explicit equation. Let's say you don't want to use your zero term. Let's say you don't want to use the zero term, you want to use the first term. So the way I would write my equation would be t of n is equal to 5. The pattern stays, that one doesn't change, so the pattern is still 5. Instead of saying n, I'm going to say n minus 1 plus 5. Again, I'm using my first term. Therefore, I'm going to take it away from the n. Okay? And let's keep doing it to see if you see the pattern. So let's say I want to use my second term instead. So t of n is equal to 5. Again, that doesn't change. N minus 2, because I'm using my second term, plus 10. Do you guys see the pattern? Let's say I want to use my third term because I don't want to find my zero term. I want to use my third term to write my equation. Doesn't let me write. Hold on. Okay, so t of n is equal to 5. The pattern doesn't change. N minus 3 plus 15. Again, I'm taking away 3 because I'm using my third term as a b. And I can keep going if I wanted to. And you can pick any of these equations to use as your explicit for the arithmetic sequence. Now you can do something similar, and let me move it a little bit up. You can do something similar with the geometric sequence, and I'll show you. Okay, so let's use our this geometric sequence right here. So 3, 9, 27, blah blah blah. Okay, so now I know in this sequence I am multiplying by 3. 3 times 3 is 9, and so on and so forth. So this is a geometric sequence. And again, because we're multiplying by 3. So now, because we're multiplying, we're not going to use this equation right here. We're going to use a different one. So this equation that we did at the top, it's only for arithmetic sequence, and this explicit equation that we're going to use now, it's going to be only for geometric sequence. That's why you need to know what it is first. So now the equation that we're going to use for a geometric sequence is this one right here, to the power of x. I'm using a new program, so I don't know how to put a parentheses. Or maybe I know what I'm going to do. I'm just going to write it in. Okay, so we're using this equation right here. Do you guys remember? But instead of y, we're going to say t of n. And instead of x, we're going to say n. So let me rewrite that the way I want it. So t of n is equal to ab, that stays, to the power of n. And again, I'm going to do it manually because I don't know how to write my exponents in this program. Okay. And then this a right here is going to be my 0 term. Again, 0 term if it existed. Same thing as what we did in the first example. And then this b right here is my multiplier. So whatever I am multiplying by. Multiplier. I'm gonna just shorten it. So that's my multiplier. So now I can write my equation right here. T of n is equal to, if I needed to find my 0 term, because forward I'm multiplying by 3, backwards I would divide by 3. So 3 divided by 3 is 1. So I know that my first term is 1. My multiplier is 3. And I'm going to take that to the power of n. And then we put it a little bit up and write it manually. So to the power of n. That's the equation that I can use, and I'm done. Now, you can do the same trick that we did at the top with the arithmetic sequence. So, for example, if I don't want to find my 0 term, and I want to use my first term right here, the multiplier doesn't change. But because I use my first term, I'm going to subtract that 1 that represents first to the n. So same thing as I did here, where I used my first term. I'm using my first term, so I'm going to subtract it here. Let's say I want to use my second term. Again, you can choose whatever equation you want to do. So let's say I want to use my second term. So that would be 9. And the multiplier doesn't change. And to the power of, this is going to be to the power of n minus 2. Again, because I used my second term. Or let's say I want to use my third term. 27. The multiplier doesn't change. And because I use my third term, I'm going to subtract that 3 to the n. So again, any of these equation works. I can even keep going. But again, I'm only asking you for one, whichever one you want to use. And this trick is useful because sometimes in like tests or anything like that in the future, they might not give you the first term. They might not give you the second term. They might give you like the 100th term. And because they give you the 100th term, you would just say minus 100. And that's just easier for you instead of going back all the way to 0 or all the way to 1 or all the way to the beginning. Okay, so that's why I wanted to show you this trick. Hopefully this helps out. And that's it.